Welcome to STEM School. Quadratics involving functions of x. For example, to solve x to power 2/3, so this is involving fraction. So this one has fractions in it, in the power. Fraction exponent. So solve x 2/3 plus 3x 1/3 minus 40 equal to 0. First of all, I just want to show you something that's really funny here. I want to show you the x to the power 2/3 can be written as x 1/3 to the power of 2. So x to the power 1/3 to the power of 2, because that then will become x 1/3 times 2, which is x 2/3. So that's giving us a clue here, because we have x 1/3 here, x to the power 1/3. We also have 1/3 x to the power 1/3 here. So if I split it up and write it clearly, I could see that that's x to the power of 1/3 all squared plus 3x to the power of 1/3 minus 40. So that's the clue there. The clue is to now let u equals x to the power of 1/3. So what I'm going to do now, I'm going to substitute that u into there. So I'm going to get u squared, because that's now u now, plus 3u minus 40 equal to 0. So I can solve this using completing the square, perhaps maybe factorization, and I can see factorization will be quicker. There's a quick way of doing factorization, but I'll do the longer way. So in this case, this resembles general quadratic equation a u squared plus bu, little b by the way, plus c. Now I can see that my a equals 1. There's a 1 here. B equals 3. There's a 3 there. C equals minus 40. Using factorization, I need alpha plus beta. When you add them together, it has to be equal to b equals to 3. Alpha plus alpha times beta, that'll be product of roots, sum of roots, product of roots, should be equal to AC, which is minus 40. Minus 40 times 1 is minus 40. So remember that this is sum of roots, and this is product of roots. Now, so I've got minus 40. I need to find my alpha and beta. So I start with 1 and 40. What can I do to add it together? Will I get 3? No way. I will go for, if I can go to 2 and 20, it still will not give me, it still won't give me 3. Now go for, well, would 3 do it? 3, I suppose, won't do it. So 4 will go. So 4 and 10, if I add them together, I still won't get 3. The next one I want to try might be 5 and 8. Okay, 8 and 5. Sorry, it should be 8 and 5 because 8, because I double 4, I get 8, and I have to double, I have to half 10. So that would be 5. So that's how it works. 140, double 1, half 40, double 2, half 20, that's 10, double 4, half 10, I get 5. Okay, so 8 and 5. 8 and 5 will definitely give me 3 because if I have minus here, and I put x here, I put x here, that will give me 3. Oh, sorry, u. I'm working on u now. So I put u there, that will give me 3u. So now I could come in here and replace this one with that. So I get u squared plus. Now, it doesn't matter where I put 5 now because 48, 5 goes in, 8 goes in 14, 5 goes in there. So I could say u plus 8u minus 5u minus 40 equal to 0. So I could say that now. So that's good. And now I could find common factor here. U is a common factor, so I get u plus 8 minus, bring the minus down. 5 is common. I get u plus 8 as well, because if I take minus 5 out, I will get u there. Minus 5 times u is minus 5u. And I have to change the sign here because I've taken minus out, so that will become plus. Minus 5 times plus 8 is minus 40, and that equal to 0. So therefore, I've got two same common factor here. So my factors are u plus 8 and u minus 5 equal to 0. So I have the solution to that is, so let me just come here and draw this line. The solution to that is u plus 8, those are the two factors, and u minus 5 equal to 0. Now, I have to set that to 0. I have to set that to 0. So that would be u plus 8 equals 0, u equals to minus 8, and u minus 5 equal to 0, u equals to 5. So now, what do I have now? I have, if I remember that u is x to power 3, so I get x to power 3 equals minus 8, which means that if so that's indices now. If we remember solving this in indices, it's what I need to do now is so to get rid of this x to power 1/3, to get rid of the 1/3, I need to cube it. So if I do x to power 1/3, if I cube it, I have to cube minus 8 cube. Let's just draw another one here, so hopefully I have enough space. So that'll become x 3/3 equals minus 8 to power cube. All right. Yeah, so let me put it onto this side. It's easier to see because I'm running out of space. So if I write it here, x 3/3 will be equal to minus 8 cube. So that's that. And therefore, minus 8 cube. So that will become x equals minus 8 times minus 8 is plus 64. Plus 64 times minus 8 is minus 512. That becomes minus 512. So that's what x is. But then I've got the second part with each, which is x u equals 5. So I would have x to the power 1/3, which is u, equals 5. Again, I have to cube this, then I cube that. So that will become, x will become 5 cube. 5 cube is 125. So the solution to these questions are x equals minus 512 and x equals 125. Here's some examples. We don't need to solve this, we just want to simplify it so that we get to a point where we can solve them. The clue here is, here's question 1, A. 2x plus 4x to the power half minus 7. In this case, I can see that there is x to the power 1 and x to the power a half. What we can do is to say, split this up if you want. You don't have to do that. So that would be x to the power of a half squared. That's what that is. Because just to, a half times 2 is 1. So that's 2 over 1. 2 times 1 is 2. 1 times 2 is 2. 2 over 2 is 1. So I have split the 1 here into a half squared. And you can see that I get 4x to the power a half minus 7. So if I let u equals x to the power a half, I can then have 2u squared plus 4u minus 7 equal to 0. So that's a quadratic equation that we recognize. So that's what we're trying to do. And when we find u, we can then replace with x to the power half. Don't forget, x to the power half is basically root of x is x to the power of a half. That's from indices, right? So that's one way of doing that one. B, and you can see here that if I multiply that out, I will get e. Now, that's e squared times e squared, ex, sorry, minus 6ex equals 8. But if you're multiplying the same base, you add the power. That's law of indices, we know that. A to the power of n times a to the power of m becomes an plus m. So we could have ex plus x minus 6ex minus 8 equal to 0. So I took 8 to the other side. And then I've got here, I get 2x minus 6ex minus 8 equal to 0. Now I can see that I can take the 2 out, so that will be ex to the power of 2. There we go. Minus 6ex, just put in bracket, minus 8 equal to 0. So now we can let u equals ex. So we'll just can let u equals ex. And that will be, so that would just give us, which imply that you're going to get u squared minus 6u minus 8 equal to 0. So that looks like a quadratic that we can solve. And then once we find u, we can replace it with ex. What about this question? This one is 5x, so this is obvious now, right? So we can write this as 5x plus 5x squared minus 4 equal to 0. So we can say let u equals 5 to the power of x. So I'm going to get u plus u squared minus 4 equal to 0. But that's not the way we write standard form quadratic. You have to write u squared plus, there's a plus u there, minus 4 equal to 0. So that's similar to ax squared plus bx plus c. Okay, what about this one here? Well, we've got 2 cos squared x is also written as cos x squared. That's the same thing. So that is also written as that, same thing. And then you have minus, bring the 5 cos in. So that would be minus 5 cos x, because there's a minus here, bring it in, it'll become, there's a plus here, it become minus. And plus 3 equal to 0. In this case, we can say let cos x equals to u. So then we have 2u squared minus 5u plus 3 equal to 0. So we can solve all this, and then we can then find cos x. And that's how we solve those.